Hello, good people. Here's video number 2. We started talking about what a limit is, how to look for it in terms of a graph. We're going to do a little bit of practice here with example number 1. I'm going to zoom in just a tad. I'm going to use the same colors to kind of keep it consistent here. So we're looking at the graph of a function. Remember that a function can be given to us in terms of a graph, in terms of a table, or in terms of an equation. In this case, they give us the graph, and the name of the function is g of x. So it says, use the graph of g of x above to answer the following questions. We have 4 limit statements. We're going to start with the first one. And I'm going to read the first one out loud. If you follow along, remember how we read it. We're going to take the limit of the function g of x as x approaches 4. Now, I want to remind you that this tells me where I'm going to focus my attention. I'm focusing my attention in the area around x equals 4. And I need to do two things. I need to come from the left side and I need to come from the right side of x equals 4. So let's find x equals 4. So that's here. We're going to come from the left side and we're going to come from the right side. So we're going to squeeze into x equals 4. And our goal is, if I come from both sides, will my fingers, in effect, will my fingers be pointing to the same destination, right? In this case, I'm going to do my fingers in this copper color, but I'm going to say my function is getting closer and closer to x equals 4 from the left, and it's going in this direction. My function is getting closer and closer to x equals 4 from the right side, and it's going in this direction. Are the two arrows pointing at the same destination? And the answer is they are. They're both heading towards 1. So I can say with confidence that the limit of g of x as x approaches 4 is 1. That's it. You're looking to see, I used to tell students, it's kind of like the finger method. If you come from the left side and you come from the right side, are they going towards the same place? Because if they are, that's your limit. Now, whether or not there's a point there, that doesn't matter. Is the intended destination from both sides, the left side and the right side, are they going towards the same place? So let me erase this and we'll do the second example here. Second example says the limit of g of x as x approaches 1. As x approaches 1. So now I'm going to change my focus. Now I'm looking over here in this part. So the question is is the graph approaching the same destination from the left side and the right side? So I'm going to go from the left side. From the left side, by the way, it's from the left, meaning I'm moving right from the left. So I'm coming from the left side. What's the y value that the graph is heading towards? I don't care if it actually gets there, but what is it heading towards? Well, if I come from the left side, it's heading towards 1. Okay, what's the y value, the function value that the function is heading towards if I come from the right side? Oh, it's going towards another y value. So if I think of it as that finger test, on the left side it's going towards 1, but on the right side it's going towards 4. Are my fingers pointing towards the same destination? And the answer is no. They're not going towards the same destination. So therefore, in this case, we're going to say that the limit of g of x as x approaches 1 does not exist. You're going to see this a lot. DNE means does not exist. If you're a fan of the movie Mean Girls, well, then you know that the limit does not exist. In this case, the limit doesn't exist because the left side and the right side are not going towards the same destination. Remember, the limit is asking, as I squeeze in towards an x value, is the function heading towards a specific y value destination? What's the intended y value destination? And in this example, from one side, it's going towards 1. From the other side, it's going towards 4. It's not going towards a specific destination. All right. What about letter C? What's different about letter C? There's no limit. We're looking for an actual function value. So this is different. This is telling me, I don't care what happens on the left side, on the right side. I care what happens here. And this is where I go looking. Is there a point? Is the function defined somewhere on that x equals 4 line? Is the function defined? Yes, it's defined at x equals 2. So the y value, the specific y value at x equals 3, at x equals 3 is 2. I'm sorry, x equals 4 is 2. So therefore, g of 4 is 2. I don't care what happens on the left side. I don't care what happens on the right side. I care what happens at exactly x equals 4. That's the difference between number 1 and number 2. Number 1 and number 2 are asking, where is it going? But number C says, where did it end up? Right? At that specific x value that we were closing in on, where did it actually end up? Not where was it going? And so when I do, and we do, letter D here, we're taking the limit of g of x as x approaches 2. So we're looking at a new focus here as x approaches 2. Well, here's 2. I'm supposed to approach 2, so let's do so from the left side and let's do so from the right side. Are we headed towards the same destination? By the way, some students sometimes ask me, how do you know how far left you need to go if you're moving towards the right? How far left do you go? Like, could I start over here at -2 and be on the graph and go to the right? You could, but remember, you have to go all the way until we get closer and closer to x equal 2. So I just start here and say, okay, look, it's going to go towards that destination. And then from the other side, from the right side, it's going to go towards that destination. And so therefore, my limit, the y value that the graph is getting closer and closer to from both sides, from the left side and the right side of 2, as I squeeze in, the y values are getting closer and closer to 1. And that's my answer. My limit of g of x as x approaches 2 is 1. So as I look at this graph, you're going to be practicing on some of these graphs in the next session. I hope that you take a look at this video to kind of get the idea. We'll do some more examples here in a little bit.